Hey guys, this is Srini here. Welcome back to my channel, and this is my part 2 in the tutorial series of Senior Automation Engineer interview questions. So today we are going to progress further on our previous part, and we're going to learn on all the Java theoretical interview questions. So if you're new to this channel, please do consider subscribing to it, and please hit the bell icon to get videos of upcoming videos notifications. Okay, so let's get started. So I have a document which I've already shared in the previous session. So I'm going to continue it further. And in the theoretical questions we had discussed in the last session about method overloading and method overriding. So this is one of the most popular question which you can expect in the interview. Now going ahead, the other important question which I have seen most of the companies asking the candidates is that about the abstraction. Now abstraction is of two types, and what exactly is abstraction? I'll come to that. So what is abstraction? Abstraction is basically like hiding internal implementation details. Okay? Hiding internal implementation details from external world. Okay, that is the basic meaning of abstraction. And I'll also explain from a Selenium perspective how the abstraction can be applied. But first, let's look at the Java part. So abstraction can be achieved either 100% or 0 to 100%. So this is a definition of abstraction, how in Java abstraction can be achieved. Now 100% when I mean is basically like an abstract class. Okay. Okay. So let's say not abstract class, let's say interface. Because abstract class will come onto this category 0 to 100%. I'll explain why and explain both interface and abstract class in this particular tutorial session. Okay. So let's talk about what is an interface, right? And how do we declare an interface, etc. So let's say we are having an interface like public interface. Let's say I enter one. Okay. I'm having an interface here, and in this interface, I'm going to declare certain variables and also certain methods. So let's say a equal to 20. Okay. And if I want to give a meaningful number, let's say sum equal to 20. And let's say we have void print sum. Okay, this is a method which I am having. And there is no return type and there is no arguments or parameters to this method. So this is how the method is there. Now, basically, this means it's basically like a final. This particular variable, whatever we are having, is basically final. Of course, we need to declare the type in sum equal to 20. So this ideally meant final in sum equal to 20. Okay. And this is actually public. What happens is whatever variables we are having inside the interface that will have public final, and then this will be appended automatically to the variable. Okay. And the method would be having public abstract. This is how actually internally the method will be taken up. Okay. And what exactly is an interface? Interface is basically like a template for classes to implement it, but it is not enforcing that you have to implement the interface. Okay. So let's say I have a class, let's say class 1, okay, which is trying to implement this interface, right? So this is how we write the keyword implements, and we will say enter 1, and I'm going to try to implement this. So when I try to implement this, what is going to happen? This particular variable will come here as if it's like inherited by the class. Okay. So when the class is implementing an interface, automatically this variable sum or whatever variables we are declaring here would be coming into the class. But we can't change the value of this variable. So if I say sum equal to 40, let's say I were to say int sum. So this is how it will be. So it should be public final, because we should not decrease the visibility less than public. So I'm going to say public final int sum equal to 40. This is not allowed. This is some important concept which you need to remember in Java. We are not allowed to change the value of a final variable, because whatever is declared inside the interface the value of a variable that cannot be changed throughout the program. It will be remaining as 20 because it is final. Okay. So this is basically like a constant you can think of. This is like a constant in Java. When you say final in front of the variable name, this modifier basically makes it as a constant variable. Okay. Now coming to this particular method as print sum. So let's try to say the same name. And now we have to give a definition. So this particular method now, we cannot change the variables. I mean, we cannot change the access modifier less than public. So we will have to tell it as public. And now we can give a definition. Let's say system.out.println. This is how we are going to give the method definition inside the class. But this is one way of how we are going to achieve the implementation of the interface via class. But let's say there is one more method, one more class actually. Let's say class 2 is also implementing the same interface. Now, I'm just trying to tell you why these all concepts are important and also why it is 0 to 100% abstraction. So I'm going to say C has to be small here. Okay, this class has to be small here. This is the class name and it is implementing this interface. Okay, and I'm having some another method here. Let's say public void print details. I'm not implementing this particular method, whichever we have got from the interface, which is that inter one, right? I'm not going to implement this method. Okay. So when you don't implement this method, you will be forced to make this class as an abstract class. Okay. Because you have at least not implemented one particular abstract method, which you have got from the interface, right? Because you're trying to implement the interface, but you're not giving a definition for that abstract method. So you would be forced by the Java compiler to make this class as an abstract class. Okay. Otherwise, it will give you a compilation error. So these are the few important key concepts which you need to remember when you're working with the interface. Now, why is the interface 100% abstraction? Okay. And why are we saying abstract class is 0 to 100%? Let's discuss on that. Okay. So when you say interface, basically, you are not giving any definition. If you look at this interface, right, you are not giving any definition. This is also abstract. There is no definition here. It's just a variable, constant variable. And whatever methods you're going to give within an interface are going to have no definition at all. It will be just like a declaration. Now we'll talk about Java 1.8 later on in our future tutorial sessions. So in Java 1.8, we have something called as a default method. So for a default method, we can have a definition inside an interface, but that is the only specific to default method, not like generally any method. So these methods basically which are not having any definition, they would be treated like a abstract method. Okay. So that is why we say interface is 100% method of doing abstraction. Whereas abstract class is 0 to 100% is because in an abstract class, let's say we're talking about this method, right? I can also have, yeah, see, this is one method, right? Public void print details. This is not abstract method. This is not abstract. Likewise, I can have another method, right? Within the same class, I can have another method. Public void get details. And this also can have a definition. So these two are non-abstract. And then we have got one more method, which is inherited, not inherited basically, but which is obtained from an interface, which is the abstract. So how much is the percentage abstraction, right? It is hardly 33.3 because out of the three methods which we have, one, two, and the third one which we have got from the interface, which is the print sum, only one is abstract method. So we have only 33% approximate abstraction, right? Out of the two non-abstract methods, we have only, out of three, we have total two non-abstract and one abstract. So that is why abstract class is basically like a 0 to 100% abstraction. So these two are a very important questions, polymorphism and abstraction. Now let's come to the next important concept of encapsulation. And of course, we have inheritance also. So I'm going to mention the next important topic. So these two also we are going to discuss in today's session in detail. So let's talk about encapsulation, a very, very important and easy concept to understand. So before we understand encapsulation, you need to understand about a terminology in detail, that is access modifiers. Okay. So access modifiers in Java are of four types. We have private, we have public, we have default, and we have protect. So what is private? Private means that if you try to make a variable private, let's take an example. Let's take an example of class 1. Okay. If I try to make this particular uh, print sum, let's say instead of public, if I make it private, means the scope of this particular method means this method can be accessible by only this class 1. It cannot be accessed by any class outside. It could be like there is another class called class 2 within same package. Say I'm having package as pkg1. Okay, this class is also within pkg1. Which one? Class 1. So how do we declare a package? I mean, how do we mention the definition of package? Let's say when you're trying to write the definition of a class, okay, and when your class starts like this way, it will be there. Package pkg1 means this class 1 is a part of pkg1. Likewise, there may be class 2, okay, which is having some definition, okay, and this is also going to be a part of the package pkg1. Okay, so like that, even if it's in the same package or another package. So let's talk about the same package for now. Even if you say private void print sum, this print sum cannot be called by class 2, even though it's in the same package pkg1. Okay, this is the first part. Second part is, if let's say I make it pkg2 for the class 2, still this class 2 cannot access anything within pkg1 class 1 because it is made as private. That is a simple thing, that only the class 1 can access the methods or variables which are mentioned as private. It is private to only the class 1. That is the definition of private. If I make it default, default means no access modifier. So default means, implies basically no access modifier mentioned, right? So when there is no access modifier mentioned, it's going to be default. So default is going to be accessible to the class in which it is defined and two classes within the same package. Okay. So print sum method can be also accessible by those classes which are present in pkg1 because class 1 is also part of pkg1. So if you look at the class 2, if I make it again as pkg1, so class 2 can access the default variable, which is default method, which is print sum. Likewise, we can also have another one, int d1 equal to 20, for example. This is also default because there is no access modifier in front of int d1. Okay, so even this can be also accessible by your class 2. So this covers the default. So we have looked at private and we have looked at default. Now let's look at public. So public is like this method, for example, right? We have print details, we have get details. So this method is made as public, means any particular class within this package. So let's say this is pkg package. This is how we give a definition of the package. Declaration that this is a part of pkg1. So any other class, let's say class 3. Class 3 is there. Okay. And always the class keyword should start with a small letter. So if class 3 is also part of package pkg1, okay, then as well class 3 can access the public one. So public can be accessed by anyone, be it within the same class, be it outside the class or the same class, right? All of them can access the public access modifier. Now let's come to the last part, which is protected. So when you say protected, so for that you have to understand another concept, which is inheritance. So what I'll do is I will cover this shortly. Okay, we'll cover shortly so that you don't get confused right now, because I will have to cover the other concept, which is basically inheritance. So I hope private, public, and default access modifiers are clear now. Concept is clear. So we'll come to encapsulation and inheritance together. So before I cover the encapsulation, I'll just cover the inheritance. So far we have covered only the access modifier. Okay, now let's cover the inheritance concept, which you have to explain to the interviewer in the same way how I'm explaining. Inheritance basically is a way of one class acquiring properties of another class. Now there can be multiple types of inheritance. Okay, I'm not going into much depth because I'll create a separate tutorial session for these all concepts if you want me to, but I'm just trying to cover the conceptual knowledge which is expected for a Java conceptual interview. So first of all, we have single inheritance. Then we have multiple, but multiple only through interfaces, basically, not through classes. So then we have multi-level, and then we have hierarchical. Okay. So we have four types of interfaces which are there in Java. So for now, for this particular session, I'm going to just focus on single inheritance just for your understanding. Let's say I have got a class A. That class A is inheriting a class B. Okay. So what is going to happen? Let's try to depict it, right? Class A is there. So I'm going to have a definition like this. So we're going to stop after we cover the inheritance and encapsulation. So class A is there, and let's say we have another class called class B. Okay. Now what happens is that class B is extending class A. Basically, this is how we tell this is inheriting. So this becomes your subclass or your child class. Whether it's called a subclass or a child class, and this becomes your parent class or superclass. Okay. These are the terminologies which you need to remember for superclass and subclass. Now, what is going to happen here is that, let's say we are having a method here inside this class, public void get details. Okay. So when we are doing inheritance, this get details method will come inside your subclass automatically because you're doing extending class A. But what can be inherited, that also is controlled, right? So let's say we have something called protected now. Okay, now I'm coming to the next access modifier, protected void get info. So even the protected access modifier methods also do get inherited. Protected can also be there for a variable. Protected int data equal to 0. So this will be inherited along with this will be inherited along with your public. Now this is very important. Why I'm saying very important? Because your protected and public are going to be inherited. Now let's talk about another one. Let's say I'm having let's say a equal to 10. Okay. A equal to 10. This is default because it is not having any access modifier. Now what if, just think this carefully, what if class A is a part of package pkg1? Okay, class A is a part of pkg1 and class B, in its definition of the file, wherever it is defined, it is a part of package 3. So it's now we're talking about the different package. Okay, both are a part of different packages. So we have seen that public and protected will be inherited, means your class B will be able to access two methods here so far, which is get info and get details, because one is public, one is protected. Now let's talk about one more variable. Let's say int name, not int, sorry, string name. I'm just saying something now, default, let's say. Okay. So we have got a public, we have got a default, we have got a protected, and we have got, let's say, a private D2 equal to 0. So private won't be inherited. as we discussed, private is only within the class. Okay, this is default, means only classes in same package can access it. So how I hope it is clear now that this subclass which we have defined class B will not be able to access A, because A is a default access modifier variable, whereas name is a public, so will be accessible. Let's say will be inherent. Okay. So likewise, the variables which we are defining here, these are the basically like the instance variables, and these are the instance methods. Means any object you create of the class, they can access it. It is accessible to the instance or the object of the class. So this is the concept of inheritance. Okay. So whatever you're defining, if it is, it can be basically inherited. It can be, it will be inherited by the subclass. Otherwise, it will not be inherited. So we'll discuss in detail about the inheritance in my next tutorial session. I'll create a separate video where I'll cover all the inheritance types with examples practically to make you all understand further. Now let's come to the important point about protected, which we have discussed so far. Now, what is encapsulation, right? Our main topic. Encapsulation means that we are going to hide the internal details, right? Hide internal details from external world. So when we say this, what we're trying to talk about is that private variables which are there, I mean the private methods, this helps us achieve encapsulation, because other external world will not be able to access the private methods, and only that within the class can access it. So that is how we basically tightly couple the variables or the methods within a capsule, such that only the methods within the class can access it, which are only for that class we can access them. So what are the very popular examples of encapsulation? We are having public void get details. So we have got a method called getter. So I'm going to create one class here. Let's say class 4. Okay. And let's have one variable private int data equal to 20. Okay. So this is private variable. I'm having a method here for getter. Getter for above private variable. So how would the external world be able to get the value, right? So they will be able to get the value only if you make a getter method. You will not be giving them access to modify this value. So you will simply say, we'll say int here, and we will say return data. That's all. So we are not going to give them a way to modify the data. How I'm saying that, let's say now I'm going to make a method as private void set data, and here I'm going to get the value of what value I need to set it. So here I'm going to say this dot data equal to data. So what is this? So this corresponds to this particular data, whatever we are having above within the class, right? So this corresponds to this particular data, and this particular data which is mentioned after equal to, that comes from the parameter. So this is how we will not be allowing any external world to be able to set the value of data, but they can only get the value. And this we can control the accessibility by either public or protected or just making it default. So this is how we are going to protect the visibility of it. We will not make it private, otherwise no one will be able to get the value of data. So that is the reason we will not make it private. So that covers the encapsulation, the inheritance. We have also covered a till date abstraction, and in the previous session we covered method overriding or and method overloading, which is a part of polymorphism. So these are the very important concepts which you can expect in the interview. In the next session or after that, I'll be covering a very important topic, that is Java 1.8, which is going to be very important. We would be having, so there is like, Lambda. I'll just tell you which all topics I'm going to cover. Lambda, then there is stream API, right? Then we have got single abstract method, right? We have got single abstract method. So all these important concepts we are going to see as a part of one tutorial session, which will be like, you can say like a master class. We'll cover all the important concepts of Java 1.8. So stay tuned for that particular video. And in the next session for this senior automation engineer interviews, I'm going to talk about certain important areas which you need to prepare for Java coding interview round. So these were the theoretical questions, right? Now you will be also getting some questions on Java 1.8, and after that, which I'll be covering in another video. But you'll be also getting Java. The fourth part is Java practical coding questions. This is very important, and this is going to decide the fate of the interview. If you are able to cover, uh, if you're able to write the code as well as compile and run the code. So I'll cover that part, and then there will be some locator related questions for Selenium questions. So we'll have a separate part for that as well. And then there will be Selenium theoretical questions. So these are very important things which you need to keep in mind. What kind of questions can be expected for a senior automation engineer? So I'm covering all of that in a skeleton here, so that I'm going to break it down into separate videos. And then you'll have Selenium automation framework questions. And then you will be having questions on DevOps. So in DevOps, basically, we will be having Git, Jenkins. These two things are you need to know for sure. And if in case possible, try to go over Docker basics. I think this should be enough for a senior automation engineer. If you know till Docker basics, it should be more than enough. And they will be asking questions on these all areas when you go for a interview. I hope this is clear and wish you all the best. And if you have not subscribed to my channel, I would strongly recommend go ahead and subscribe to it. Thank you so much.